broad and as deep in as that course, but we're going to focus in on just running NanoServer as a Hyper-V host. So that is the context we're going to aim for as part of this virtualization course. We'll then move into something that we deliberated on. What can we call this next module? Making Hyper-V better for people.
It's a terrible name.
It is a terrible name, but we couldn't come up with anything better, so we landed on driving operational efficiencies. The marketing side of me came out then, I think.
I wanted to say make things suck less. I think that's what it is.
Great.
But apparently, no.
It's out there now. It's out there. But we went with operational efficiencies. Name it how you will in your mind, that's fine. We're going to look at security, isolation. Those things are different. Ben assures me they're different things.
Yes, very important.
Although in my mind I thought, they sound similar.
Nope.
But they are different, and we'll cover where and how and why they're different in those respective modules. Then we're on to keeping stuff running. Availability. What have we done in the product to make things more streamlined, keep your applications and workloads up and running more efficiently and for more of the time?
Honestly, one of my favorite topics.
Yep. Cool. And then scalability, running Linux on Hyper-V, upgrades, because at that point we'll have told you loads of stuff that's in the next version, reasons to upgrade, but we're going to talk to you how to get there more streamlined than ever before. And then finally, an area that is passionate for Ben, I'm getting more and more passionate about it the more I understand it and get my head around it, is containers.
Super excited to be talking about that. Really, really great technology.
Drop the super excited at this stage.
Yes.
Like 10 minutes in.
Yes, yeah. I have dropped the super excited, and that's the one to drop it on. There's no question.
Okay, fair enough. And then we'll wrap up with some resources. Some modules will be very, very short, just bite-sized, plenty of demos. Ben has got this mini data center, as he calls it down here, data center to everybody else.
You got to put extra R's. Data center.
Data center. It's under the desk. You can't see it, but there's a lot of heat.
Yes,
and,
it's good.
It's coming from the laptop, I assure you.
Warm yourself by the computing
yeah, on a cold winter day. So, without further ado, let's take us through Module 1, this introduction. And Ben, you're going to take us through a little bit of the history, looking back, and the design decisions that have influenced up to this point Windows Server 2012 R2.
Yeah, absolutely. So as I mentioned, I've been working in virtualization forever, and it's been a really fun ride. And one of the things I like to point out to people when I talk about everything that's happening in virtualization is, back when I was first working in x86 virtualization in 2000, 2001, I actually remember sitting down in a room of engineers and discussing the idea of virtualizing, traditional x86 servers. And the number one question from the room was, well, if we did that, would people actually want to virtualize servers? And that's such a strange thing to think about. But back in 99, 2000, it was just such a radical, revolutionary idea that you would want to virtualize servers. So we've been working on this idea for ages. And, Microsoft acquired us. We started working on Hyper-V, where the core premise was, let's build a server virtualization platform that's designed from day one, from the ground up, to be the way you would do this for Windows. And we've been working and iterating. And really, Windows Server 2012 was a huge release for us. We brought a whole set of technologies to market. And there was, kind of an acknowledgement from our customers, from our competitors, from the industry as a whole, that Windows Server 2012 was kind of when Hyper-V arrived on the scene. Mm-hmm. For the first time you could look at this and go like, yes, there is really no reason why you shouldn't use Hyper-V for a private cloud deployment, mm-hmm. In your enterprise, medium business, etc. Mm-hmm. It was a great release. And so since 2012, we've been looking out to what's the next wave, what's the next generation. And in a lot of that, what we've been doing is we've actually been looking at the ideas and the learning and the experience that we've gained at Microsoft running Azure. Which is a hyperscale cloud. The size of the Azure cloud is staggering. Yeah. Which has forced us to come up with techniques and different ways of being more efficient and different ways of thinking about virtualization. And so we're now on a journey where we're taking our learnings from Azure and we're trying to figure out how we can make those applicable to everyone. and make it so that the whole world can benefit from the cool technology that we've been building to solve these problems at Azure scale.
But there's also going to be things that go the other way as well, isn't there? So
yeah, absolutely.
Stuff that gets developed on premises for specific customer scenarios, service provider scenarios that initially might not be relevant to Azure, but as we go forward, there's nothing stopping them taking that as well.
And the fun thing is, like, these days we're building up quite the laundry list of technologies that I can point to and be like, hey, that was developed first here and it came across. My favorite classic one, the ability to boot a physical computer from a VHD, a virtual hard drive. We did that first for Azure. That's part of the Azure infrastructure, and then we're like, hey, let's bring that across. A flip side example, we built Replica for small businesses, and now we're enabling you to do Replica to Azure. Similarly, we have great expertise in backup in the enterprise space, and we've been bringing that across into the Azure space.
Nice.
So we have a lot of technologies flowing back and forward, and even as we're going through this course today, there's going to be times when I'm going to point out and be like, hey, this is actually something we built first for Azure, and now in Windows Server 2016, we're bringing it out to the entire world so that they can benefit.
And you mentioned that customers are starting to recognize, or customers in 2012 are recognizing, and partners were recognizing that the product was at a point in terms of its capability, its scale, its performance that could meet the needs of the vast majority of organizations out there. But since that time, we've been recognized by various analysts in their respective reports that also back that up. So it's not just about customers and
absolutely.
It's also about analysts like Gartner, for instance.
Yes. So this is actually, I've got 2 points to talk about here. The first one, and both of these are really interesting. The first one is like nice and narrow focus to my space. Is Gartner just recently published their analysis of the x86 virtualization space, and for the 5th year in a row, Microsoft was called out as a leader. And that's a great thing to see, and it's great to see. And if you can actually go and you can access this report, you can look up the historic reports. And I did a time history analysis, and it's actually really nice to see Gartner's acknowledgement of the areas that we've been improving and working on. So, if you go back 5 years ago, you can see they're saying that we're a leader, but hey, here are the weaknesses. And then, a year or two later, those are no longer the weaknesses that they see because we've been listening to that feedback and improving. But really, for me, the more interesting one from the analyst is if you step up a level from just the x86 virtualization. Because as we were just talking about, we're in this mode now where we're taking our learnings from Azure and using that to shape the technology that we deliver to enterprises. And Gartner is an analyst that does analysis across a whole broad range of technologies. And Microsoft is the only company that has been identified as a leader by Gartner in x86 virtualization, what I do, but public cloud storage, public cloud infrastructure as a service, and enterprise application platform as a service. Now, most people today, you're not just using one of these technologies. You are using all of these. You do want a strategy where you can use the right cloud technology for the right business problem. And it's great to be in a position where we as Microsoft can say, we are a leader in all of these technology areas.
Excellent. And we can hear from some of the customers as well. On the next slide, we've got some examples from Domino's, Tieto, Standard Life, all demonstrating different benefits, but they're all part of the same platform. So for instance, Domino's, they've got a vastly spread out, or distributed, to use perhaps a more accurate term, it's just spread out infrastructure, a distributed infrastructure in each of their stores. And quite frankly, if servers go down, they lose money. They get down. And that's a big problem. So having Hyper-V gave them more reliability, more availability, and again, it's a module that we're going to talk about later in the course. But you look at the Walsh Group, they benefited from live migration. We were the first to include this in the box at no charge. It was just built into Windows Server. So we're giving you features and capabilities, and we'll go through some of those that are already in 2012 R2 that set the baseline for what's coming next in 2016. But you see that people are benefiting significantly, and it's not just about Hyper-V, it's also about Azure as well. So when we think about the customer momentum there, EMC, GE Healthcare, These are organizations that are benefiting from the cloud. In addition to their on-premises infrastructure, it's unlikely that they're going to just shift everything on day one over to Azure. It's very much about extending and utilizing a hybrid infrastructure, but for new workloads, you'll see in the bottom right, standard life. They can launch their new extranet in 6 weeks versus up to 8 months for new servers, procurement, all of that stuff to arrive. So the speed of which you can achieve your goals in the cloud is dramatically quicker than traditional on-premises. But that's being said, and as Ben said before, we're taking a lot of learnings from the cloud by bringing technology on-premises, as we'll talk about in a few minutes. Bringing those Azure-like experiences, Azure-consistent experiences on-prem, means that you, even with on-premises technology, can achieve deployments of minutes or even quicker versus what?
Little side story here. My family and my wife in particular have to put up with the fact that given the choice, I will use people who I know who are using Hyper-V.
Right.
So when we go back to Australia, I'm always like, we need to get some groceries. We're going to Coles.
Right.
Why are we going to Coles? Because they use Hyper-V.
That's very particular of you.
I support people that support my technology.
Nice. Excellent. So to give people a grounding, because this course is all about 2016, but we can't cover everything that is in 2016. We want to make sure that we're focusing on what's new. There are a number of MVA courses on Windows Server 2012 R2 that will help you build your knowledge from the ground up. There's some great courses on with demonstrations and labs and all sorts of stuff on 2012 R2. But as a quick recap, give us the story so far in perhaps 5 or 6 key areas, Ben. You know, you've got scale, you've got networking, agility. Give us some of the key takeaways that people should know about the product in general up to now.
So let's talk about scale first. We have phenomenal scale numbers. It's been this was in Windows Server 2012. We really, we had a team working on this who their official title was like performance and scale or someone, but the dev manager responsible for that used to say that his title was no SQL Server cluster left behind.
Nice.
Because that was identified as like the big workload that people weren't virtualizing was that SQL Server cluster, and we wanted to make sure you could virtualize any workload.
Right.
So some staggering numbers here. 64 virtual processors per virtual machine, 1 terabyte of memory per virtual machine, 4 terabyte of memory in a physical host, 320 logical processors in a host, on and on and on. Now, one thing that I do want to highlight here is for most people, these are, let's be honest, fantasy numbers. Mm-hmm. Do you have a terabyte of memory in your service?
No, in my laptop I do.
Oh, well, yeah. I only have 32 gig in my laptop. I feel less open.
I actually do have one server that's got half a terabyte of RAM.
But so for most people, these are fantasy numbers.
Yeah, absolutely.
And I've had people come to me and say, hey, Ben, come on, how real are these? Mm-hmm. And one of the things I like to talk about is when we work on performance and scale on the Hyper-V team, we do not sign off on a performance and scale number unless we have tested it at load in a real-life customer scenario. So I can tell you when we were working on the 1 terabyte of RAM for a virtual machine, the goal we set ourselves was we said we want a max-size virtual machine. So 64 virtual processors, 1 terabyte of RAM. We want it running an active SQL workload that is using 100% of the resource. We want the CPU hot, we want the memory hot, we want everything used, and we want to be able to live migrate that virtual machine back and forth between 2 physical servers and not drop connections. Mm-hmm. And that's actually the test we did. And we can do that. So all these numbers are numbers that we've tested and that we stand behind.
Nice.
So that's scale.
Yep.
The next thing is talking about a lot of the agility and mobility and features. And one of the key things when we talk about moving from just doing server virtualization and consolidation to actually doing cloud computing, you start hearing words like elasticity and being able to respond and react quickly. And we have honestly a huge list features about allowing you to easily move virtual machines through our various live migration and storage migration technologies, and also allowing you to resize virtual machines and tweak how much resource they're using so that, as your workload changes, things change with you.
Without downtime.
Without downtime.
Yeah, so while the VM is running. But tell us a little bit about, because 2012 you had live migration, then we introduced at the same time compression for live migration and SMB direct. Just because these are, for me, I think these are killer features for people who use live migration.
They really are, and the live migration with compression is fantastic. The live migration with SMB direct is jaw-dropping. It is astounding. One of the things, anyone who's used virtualization technology with any form of live migration is very used to the idea that, like, hey, if I need to patch a server, if I need to do maintenance on a server, it's very easy for me to live migrate my virtual machines away, and then I can take down that server and do my operations without affecting things. But once again, this is lessons learned at scale. As if you're in a test lab and you just have a server with a couple of virtual machines and you live migrate them away, great. But if you're looking at 16 physical computers with 256 gig of RAM each and 100 virtual machines on them each, and you now have an update that you want to roll out through that, and you're just crunching the numbers of moving all those virtual machines around on a traditional 10 gigabit network, that's about 12 hours, which is a long time. And so we invested in two technologies in 2012 R2. The first one was compression. And with compression, what we do is we dynamically gather any spare CPU cycles and we compress the data that we're sending for live migration. And the result is, on average, we see about a 3 to 4x speed improvement in how fast we can do a live migration. And this is with no hardware changes, so on. And so, your 12-hour thing just became 3 or 4 hours, which is a lot more manageable. But the real magic is the live migration over SMB direct. And here, we're actually able to utilize hardware-accelerated RDMA-based networking. And the speed that we achieve for live migration is staggering. We have actually had rigs where we set up with the right hardware, where we were able to get live migration happening at over 16 gigabyte a second, not gigabit, gigabyte. And we were actually able to do the patching of a 16-node cluster in under an hour on that sort of hardware, and it is just staggering.
Nice.
So that's agility. Next one, of course, is availability. And we're going to be talking a lot about this today. We've done a lot of work in Windows Server 2016. One of the things I always talk about is there has never been a release of Windows Server where we haven't brought out some new feature to keep your virtual machines up and running. The one that I'm actually really excited about in Server 2016, I was excited about this in 2012 R2, I'm even more excited about it in 2016, is all the work we have going on around shared VHDX. And the reality here is that for a long time, no matter what platform you're running on, the idea of running a cluster inside of a virtual machine has always been kind of a second-class citizen, as it were. You could do it, but you give up a lot. And it's not fun, it's not easy, it's not as flexible or as intuitive as we would like. And we've been doing a lot of work with shared VHDX to be able to give you enterprise-grade clusters inside of virtual machines that are as easy to manage as just other virtual machines. So that's pretty exciting. There's networking. Is the next area we've been investing in. This has actually been a huge area of investment, and I could honestly spend an entire day.
Well, it's funny you say that, because we will have a dedicated Microsoft Virtual Academy course.
Fantastic.
I say will have. Maybe you're watching this sometime in the future. We may already have. Do a search on NVA. But there will be a Windows Server 2016 networking deep dive as well, where we're going to go through a lot of this stuff. But network virtualization, so software-defined networking built in, the gateway to extend those, to break out of those virtual networks onto regular networks and also extend to the cloud. Security capabilities built in there as well. Improvements in teaming in the box that was introduced in 2012 and enhanced in R2. All of those things are very important.
The last 5 years have really been an amazing time for the technology happening in enterprise and cloud networking. And really, I'm glad that we have a day scheduled for that, because goodness knows it needs a day. There's
quite
a lot
complex.
of stuff going on there.
Yeah, there's quite a lot to learn, especially in the new. I mean, 2012 R2 was when you first tried to get your head around it, it was tricky. You know, software-defined networking is very much a change in mindset and how you do things, how you deploy networks, and so on. And the configuration is tricky if you don't know what you're doing. But going forward, there's even more to think about as we take on more advanced networking services and bring them into the software stack. So definitely check out that course if it's available. If not, check back in a couple of months and it probably will be. So what about non-Windows platforms, non-Microsoft platforms? How do we play with that?
Very well, actually. We do a lot of work to ensure that, and I mean, the attitude and the mentality here is wherever your workload runs, we want it to be able to run well on Hyper-V. And so we spend a lot of time. A lot of people don't realize this, but in supporting Linux and FreeBSD, we actually have people on the Hyper-V team actively contributing to the Linux kernel. You know, as we're making changes, as we're adding new features in Hyper-V, we're coding those up on Linux as well. We're contributing those. We're bringing that all together. And there's a bunch of technologies I'm going to be able to talk about today where I'll be able to say, like, hey, this is new coming in 2016, and you know it's coming simultaneously on the Linux side. So that's been a huge area of focus for us.
Yep, so we do have a module a bit later on in the course where we will go into some of that stuff. It's not a drastically long module, but it does focus in on just what we're doing around Hyper-V and running Linux workloads. And there's some cool stuff, and it will probably surprise you just how well we run Linux if you haven't kept up with Hyper-V over the last couple of years, and maybe you don't run Linux in your environment. It's good to know still. So that's a little bit about, I guess, the story so far with the core areas, but there's still some more stuff in Hyper-V that, again, I suppose it fits into that operational efficiencies kind of, although Gen 2 is, I think, more than that. But tell us about some of those. Tell us about Gen 2 in particular.
And the and more bucket.
Yeah.
You know, it's something that we really enjoy working on the Hyper-V team. Is we spend a lot of time listening to our customers, listening to their pain points, figuring out how to address that tactically. We spend a lot of time working cross-company inside Microsoft, aligning with the bigger strategies. But it's also something we love to do, is to make sure in every release we have something that we're just going out there and doing to innovate, to try and come up with solutions, ideas that people aren't talking about, just to you know, get new stuff out there. And yeah, some of the key technologies that have come out in this bucket, the Generation 2 virtual machine. There's a lot of fun building, and it's been really interesting to watch people's reaction to it. This is a virtual machine that has been designed to only be a virtual machine. You know, when you look at traditional virtualization platforms, we spend a lot of time making it look like a physical computer. So that various operating systems can run and so on. Generation 2 virtual machines were designed from day one to be the best virtual machine they can be. And they've got some really interesting properties as a result.
We'll see also as we go through the course, there's a lot of things that are new in 2016 where they only apply to Gen 2.
Yes.
So we'll make sure that we try and call that out as well. But yeah, a lot of the new things, it needs a Gen 2 VM, it needs Gen 2. And because of that specific reason that Ben called out, it's been designed to be a virtual machine.
Yes, so it really opens the doors for what we can do and what's possible with virtual machines, which is pretty exciting.
And all of that is built in.
Yes.
To Windows Server, which is great.
Yeah.
So tell us about where Hyper-V and virtualization fits in this broader landscape of running your applications and workloads.
We just missed the pretty animation, as I love.
And we can revert. Let's do one more.
Let's go back. Let's do that again.
Somebody spent a lot of time building it.
Oh.
Woo!
That.
Yeah.
I don't want to know how much time was spent on that.
Well, I don't know.
So this is a really important conversation to have, and this comes back to talking about, you know, how we're taking the learnings from Azure and so on. The reality that we see for most people today is that where the world is today, there's a high penetration of server virtualization in the industry. And when it comes to saving your company money, enabling new scenarios, continuing to earn your paycheck as a CIO or server administrator or IT manager, we're getting towards the end of what you can get out of traditional virtualization, consolidation, like just let's stick those things in virtual machines and manage those. This isn't to say that these are bad things, and this isn't to say that we're not still investing in those, but we're definitely seeing that we're not in a world where if you're just focused on virtualization and consolidation, that in 5 years' time you're going to have made huge differences in your architecture. When we look at the next 10 years, where we see the next wave of efficiency, the next wave of business advantage coming from, as people sit down and start thinking about, okay, given the prevalence of virtualization, how do I design applications, design new infrastructure that assume that we have a cloud underneath. We have, whether it's private or public or whatever, we have a cloud, we have this infrastructure. Now let's start building apps that take advantage of it.
Yeah, and what is the quickest, most efficient way that I can get my application, if I'm a developer, out?
Yes.
I don't want to be held back from developing my application by taking a week to get a virtual machine because of the procurement process of a VM. Maybe I have to go through some kind of audit process. Maybe I have to go through some kind of request that needs approval. Or I'll just go to the public cloud because I can put my credit card in and go next, finish, and I've got a VM and I can start work. And that's why we see that shadow IT that's called out on the slide. Even when organizations have got virtual infrastructure in place, sometimes there's still hoops for them to jump through that mean as a developer, as an application owner, it's quicker for me to just say, need a new VM, I'll go to Azure or an alternative public cloud, put my credit card in, charge it back to the company, maybe not, and then deploy that VM and get to work in minutes versus what could be hours or days or even weeks, and even longer if it's a physical procurement. So applications are really fueling how infrastructures going forward are thinking about their data center. And it's an opportunity, we can see from this graphic on the slide, if we compare where a traditional data center is today for most organizations and an Azure data center where we have to do things at the highest levels of efficiency through automation, standardization of key processes, configurations, because if we don't, it costs us more time and that costs us more money. If you think about when you use Azure as an example and you deploy a new VM or you deploy a new virtual network and you've given it an IP address range and subnets and whatever else, there isn't somebody running around in the Azure data center with 2 cables, plugging them in. Oh, we need another VLAN, quick log onto that switch. Oh no, I can't find the serial cable. It just wouldn't scale. It would just be impossible. There's something like 50,000 network changes a day in Azure.
Yes, it's staggering.
And that kind of thing has to be standardized. It has to be consistent. It has to be driven by software. And if you think about the way Azure utilizes hardware, it's not using expensive, specialized, focused hardware. It's using industry standard x86 servers and storage and using the power of software to transform all of those into something that it, as an entity, Azure, can control more efficiently and ensure that you, who is consuming an application essentially or a workload from Azure, can do it in the most friction-free manner. Because that's what we want to do. We want to make sure that you can log in, you can deploy a new website in a minute, or you can deploy a new VM in a minute or two. It's that kind of frictionless.
Kind of long.
A minute is a bit long, but I think for a VM it does take a little bit long because it's got to go through that whole out-of-box experience. Technicalities, it is a minute. Somebody will pick me up on that. It's actually 4 minutes. But the reality is a couple of minutes, but it's friction-free. You just next, finish. And when you click, the next time you log in, you've got your VM and you're away. So those key things, they're very different from that traditional data center where you have got applications tied to certain locations, perhaps. Maybe we can't move that VM because of the VLAN that is attached to that rack. And if I want to move it to that rack, then I'm going to have to do some manual network configuration. SDN helps solve those kind of problems. We don't need specialized hardware because abstracting that away in virtual machines, in a virtualized infrastructure, it gives us so much more flexibility and it means we can reduce our hardware costs as well. So certainly think about the applications you want to run, how you want to run them versus specializing on certain types of hardware and siloing things. We want to make this pool of resource that is our data center and just run stuff on top. And Azure is really influencing our design even further as we go forward.
Yeah, so I'm waiting for them to put the slide up so I don't blow the next animation.
Here we go. You ready?
Ready? 3, 2, 1.
3, 2, 1. Look at that. See? Look at that.
Epic.
I actually went forward and then I went back and I was waiting.
I did see the shock in your face. Was like, wow,
that's an animation the world needs to see.
Absolutely.
So yeah, I mean, the key thing to highlight here is, you know, we started on this journey with Windows Server 2012 R2, and with Windows Server 2016, you're going to see more so than ever, you know, us talking about, hey, how do we bring Azure technologies on premise? How do we change the way we build applications? And you're going to hear us talking a lot more about the architecture of applications than we have in the past. Because as I've been saying, you know, we believe the next wave of innovation is, okay, you've got your cloud in place. How do you start building the apps and building the infrastructure on top of that to really take advantage of that?
And we mentioned right at the start the influences that are coming from Azure, into Windows Server, into System Center, and up until recently, there's been the Azure Pack, which was an Azure experience, UI, websites, IaaS virtual machines that you brought on premises and sat it on top of Windows Server and System Center and integrated the 3 key components. And you had an Azure-like experience on premises, albeit it was the look and feel, but it wasn't necessarily identically consistent with what exists in Azure from an API perspective and all the services you could consume as well. Going forward, as we can see on the graphic here, we are bringing absolute consistency on premises in the form of what we call the Azure Stack. Now, Windows Server, Hyper-V will form key components of this Azure Stack. As
they do in Azure.
Exactly.
Which is the important thing to point out here.
And what this means is by increasing the level of consistency to true, we're bringing code on premises now as well. You'll have this cloud-inspired infrastructure on-prem powered by Windows Server, System Center, and Azure technology, as Ben has alluded to as well. But on top of that, you'll have the rich portal that you can experience in Azure, and you'll have the IaaS and PaaS services, so platform as a service, for running your key applications, workloads, whether they be based on Windows Server or Linux, whether they're VMs, whether they're containers, whatever it may be, all of that will be available for you. So we're really amping up that consistency. And the end goal is flexibility for you. You deploy your app or you build your app once, you deploy it anywhere. Because me deploying to an Azure Stack on-prem is no different, albeit the destination is different, but the actual underlying infrastructure, it won't matter.
The experience, the code, everything that you touch as the user and as the developer is the same, which is awesome.
So that brings us to the end of our first module, which was an introduction, a bit of strategy, and a little bit of history about Windows Server 2012 R2, Hyper-V, and hopefully you understand now where it fits as part of the broader picture and where we're going towards with things like Azure Stack. But in the remaining modules, we're going to just dive into the technology. Specifically in this next module 2, we're going to be focusing in on Nano Server and how you can use that as a Hyper-V host. So join us in the next module. Thanks.
Thank you.